In this lesson, I will show you how to image and verify a thumb drive using Linux. I'm using Mint 11 here, but you can also use Ubuntu as well. And in fact, you can use any version of Linux that you like. But I'm going to be using Mint here, and it works the same in Ubuntu. And one of the things I'm going to do is to stop auto-mounting of drives. And so what that does is that decreases our chances of accidentally writing out to the drive. Obviously, from a forensic standpoint, we want to make sure that we don't make any changes on the original drive. And as I described previously, one thing we can use is a hardware write blocker, which sits in between the media and your forensics examination machine, and that will allow you to read from the drive but not write to the drive. Since I don't have one here, they're quite expensive. I do have quite a few in my research lab though, but that's in Orlando. What I can do is to stop the auto mounting of the drive. We can mount it manually, we can mount it read-only, and that will ensure that nothing is written out to the drive. So our objective in this lesson is to look at how to use Linux to create an image and to verify the image so that we can compare across tools to see if the tools are working in a similar fashion. And so here I've got Mint 11 running, and as I've described before, we want to make sure that we use sound forensics procedures. We want to make sure that we don't taint our evidence by accidentally writing out to it. And so the way to do this in Mint and in Ubuntu, if you're using the GNOME interface, is to use the gcomp editor. And what that allows us to do is to go up to Apps, and then Nautilus, which is part of the GNOME environment, and go to Preferences. So Apps, Nautilus, Preferences, and we can scroll down to, notice here these two lines, Media Auto Mount, Media Auto Mount Open. We can uncheck those, and we can close. And now when we insert our USB thumb drive, that media should not be mounted. Now this doesn't work the same as it would for a physical hard drive in your computer, because that's controlled by the FS tab. In fact, let's take a quick look at that. The FS tab file, which is located in the etc directory. And this controls the mounting and unmounting of the physical hard drives in your computer, as well as your floppy drive here. Notice that there's nothing mentioned in here about a USB drive, but there is the two partitions right here. There's SDA1 and SDA5 that will be mounted, and the etc FS tab file controls that. Let's get out of there. Okay, so I've already got my Memorex. Now let's go back and run sudo fdisk-l, and wow, this Memorex. We'll notice that first. Let's just walk back up here. That the virtual hard drive is 8 gigs. And if we move down, we'll see that we have dev SDB, which is 132 megabytes, which is our Memorex thumb drive, and it's reporting a lot of errors, and it says this doesn't look like a partition table, but this was formatted in Windows, and the files were copied in Windows, and so occasionally you may see something like this, but normally, even when you plug in and it's giving us a number of partitions too. That's really interesting. So actually, I don't know what the issue is here. You probably won't have that issue. But let's go ahead, and because this is just evidence that was given us, right? We have to deal with it as is. This is not something we want to fix, obviously. This isn't an IT job. This is a forensics examination. And so what we want to do is that we want to create an image of the file, then we want to hash it, and then we'll compare those hashes to the hashes that we computed in FTK Imager and in ProDiscover. Recall in FTK Imager we computed two hashes. We computed an SHA1, Secure Hash Algorithm 1, and an MD5, and ProDiscover an MD5. And so let's go ahead and we want to image SDB. And so let's make a directory, evidence, and we're going to use the dd command as we saw in the previous class. And we want to take the entire disk, the whole disk. SDB1 would be the partition, SDB is the entire physical disk, and our output file is going to be named, let's call it and our block size, we can bump it up a little bit just so that we can increase the efficiency and the speed of reading the file. Recall that the default is 512, and by increasing that about 8 times it should speed up the reads from the Memorex. And we don't want to set the count because we're going to be reading from the first byte all the way through the end, so we want to make sure we get it all. Oops, and oh, I'm glad I did that, because now you remember. And so we want physical access, so we have to run that as sudo. And unfortunately, dd doesn't give us any indication of the progress. So I'm going to pause this video and I'm timing it, and I'll let you know how long it took. So it took about 2 minutes. So for each tool we've used, it's taken about 2 minutes to do the imaging. And now what we can do is we can create an MD5 of the file. See that it's there. First of all, let's run file on this, because what it will do is this will give us some interesting information about the contents of the file that's taken from the master boot record. Notice it has an MBR, number of root entries, the media descriptor F8. We saw that previously when we were looking at the physical contents. And the serial number. This says it's unlabeled, so I guess it's not reading from the root directory entry, indicating that the label is actually pkrager on this. And then we can run the MD5 sum on this. And we'll see if that's correct. Interesting, that is not correct. Oh, and this is, so what I've learned is by going back and or re-verifying the Memorex thumb drive, is that the hash has changed. So clearly, sometime in between using ProDiscover and using Linux, something in there has actually changed the formatting, or change something on the evidentiary drive. So this is a great teaching moment right here to illustrate the fact that why you need to be able to use a write blocker, or to do something that controls for any writing that goes out to your evidentiary media. And so this is of great importance, because if for some reason, let's say you worked in law enforcement or you worked for a large company, you did the forensics examination, you did an initial hash, and then you examined the evidence, and then you came up with another hash, you would have to have some way of explaining why those hashes were different. Did you add something to it? Did the examiner place evidence on the drive? It also shows a lack of competence on the part of the examiner in not being able to perform a forensics image or an examination without changing the evidence. So that's why it's important to use a write blocker. Not knowing why there was an issue with the partition table, let's use another my little 64 megabyte Swiss Army knife USB drive and take a look at that in Linux. Okay, so I have my 64 megabyte Swiss Army knife USB device in here. Let's go back and check the disk partitions. Obviously this is not connected up here. Let's go back up here. Let's install the device drivers. Come on. Okay, such are the trials and tribulations of doing a live exercise. Linux did not have the drivers available for my Swiss Army knife USB drive, so I found a 16 megabyte drive. We're getting smaller, and I put a few files on that. And so what we want to do is go through the process of imaging and verifying that. And so first we need to make sure that that's connected up here, movable devices, and we want to disconnect from the host, which is going to connect to VMware. And now if we run sudo fdisk-l dev sdb 16 megabytes, and this tells you specific information about the virtual physical architecture of the device. See, it has a single partition that is FAT12. We'll run file on first. So let's clear that, and now let's create an MD5 of the device. And let's write it out to sdb.md5. And by running it before and after, what this allows us to do is to show that by imaging, we haven't changed the device. And that might be considered overkill by some. Some examiners will only do a single verification. This is small, so we can do it quickly. So there's the MD5 of the entire physical device, 7C83AF. So now we can do the imaging. And that was very quick, so now we can go back and do re-verify. And let's see what it looks like. Okay, so our imaging didn't change our physical device, so we know we have a good copy. And just to make sure, let's check mount. Did it mount it? No, it did not. But using Linux, we still have that access to the physical device. And if we want to run file on this, we can see that the FAT12 has more limited information than the FAT16, the FAT32, and NTFS. Okay, so now that we've seen what the MD5 is, let me write down this. Since the Memorex MD5 changed, let's go back very quickly and look at the MD5s of the physical device with FTK Imager and Pro Discover. And this should run very quickly. And there's our 16 megabyte USB device. And let's verify it. And the NV5 hash 7C83AF, that's correct. Close this out and we'll go back and use Pro Discover. So now we can go to Pro Discover, project number, and second try. We can go back up to Add and select our drive, destination. Let's go to DD, and we'll use a Unix type format, and we'll see if we get the same hash. Okay, now we can go out desktop and second try. And that's very funny because that changed. Yes, that's interesting. So, you know, actually we received several errors in doing this, but what that suggests is you have to be careful about the tools you use, and you're careful that you test them. When doing your validation assignment, you get what you get as long as you follow the proper procedures. We created an image. We verified them. In some cases, we got different hashes, suggesting that something was changed, or and just for giggles, let's go back over here and see if FTK Imager will give us the same hash as previous. Okay, interestingly, I now get the same hash as I did as previous, and Pro Discover gave us a different hash. So do I know what the problem is? No, I don't. But what I do know is that they gave me different hashes. So two of the three, the MD5 Summon Linux and the FTK Imager provided us the same hash, whereas Pro Discover provided a different hash. The idea behind the procedures that we've performed here is to test our tools. So what does that tell us about our tools? I'm going to let you draw your own conclusions. But when two tools give us correspondingly different information, a Obviously, you might want to try a different tool to see if you can get the same results as either the first tools to try to identify which one is giving you the erroneous information.